Hi everyone. Today we will continue with our lesson interval notation versus set notation. First topic is union of sets. The union of two sets A and B is the set of elements in A in B or in both. The symbol used to indicate the union of two sets is U. We use union symbol to combine two or more intervals together. Let's understand this with an example. The interval x is less than -5 or x is greater than equal to 3. What does this denotes? This denotes the set of real numbers less than -5 and greater than or equal to 3. Let's let's understand with a number line. Okay. So when I'm saying x is less than -5, -5 will lies exactly in between of -4 and -6. Okay. But you see, we have not included -5 here. That's why I'm using a hollow circle. And it tends towards infinity in one direction. Similarly, for x is greater than equal to 3, 3 will lie between 2 and 4. Here 3 is included. That's why we are going to use a solid dot. The concept of solid dot and hollow dot is explained in previous lecture. If you haven't seen that, please go and watch in the playlist. So x is greater than 3. So this is tending towards infinity in the right direction. So how we will write this union concept in interval notation? See, minus infinity to -5. Since x is less than -5, so minus infinity to -5. where 5 is not included, union 3, 3 is included, so we are using a square bracket, 3 comma infinity. So in this way, we are expressing the above intervals in interval notation. I hope this is clear. Now let's understand what is set notation. So set notation is a flexible, but we can say it is slightly more complicated way of writing down sets. It is an alternative method to interval notation. Let me explain you what is a set. A set is a collection of well-defined objects. And in math, we encounter sets very frequently. I will explain you with an example. Suppose we have a list of numbers 0, 1, 2, 3, 4, 5. We can call our list of numbers a set. And we can label it whether we like. So let us call this set X. Therefore, the list of numbers in set X is you can notice here sets and set notations are delimited by curly braces. Now we will move into some common sets. First, we will talk about set N, which is natural numbers. All the positive numbers except 0 comes under natural numbers. Next is set W, which is whole numbers. All natural numbers including 0 is whole numbers. Next is set Z, which is integers. All positive, negative numbers, including 0, comes under integers. In this way, we usually denote sets. Remember to apply curly braces. Next is Q, set Q, which is called rational numbers. All numbers which are in the form of A by B, where B cannot be 0. So our denominator cannot be 0. In this way, we write the set notation for our rational numbers. Then irrational number. We can say the numbers which are not rational numbers are called irrational numbers. So all x which are not in the form of A by B, where B cannot be 0. And the last set is R, which means real numbers. Real numbers are all rational numbers and irrational numbers. So we can write it as Q union I. Now we will understand how to write set notations. So in the previous video, we have learned about interval notation. So this is an alternative form of notation, and we can also use set notation wherever required. So I'm taking the same example, -5 to 1. You know, this denotes the set of real numbers between -5 and 1 inclusively. We also know how to show this on a number line. So -5 will lie somewhere here, and 1 will lie between 0 and 2. We will use solid dots. This is how it will look. So now the time is to understand how to write this in set notation format. You see, x here can be any real number such that x should be greater than or equal to -5 and should be less than or equal to 1. So in this way, we can write our set notation. Let's take another example. Here we have used parenthesis. It denotes the set of real numbers between -5 and 1 exclusively. That means -5 and 1 is not included. Let's again draw a number line. So -5 will lie somewhere here and 1 will lie here. Remember, since it is since it is parenthesis, we will be using hollow dots. So in set notation, we will write like this. X can be any real number. Here this belongs to. This is called belongs to. X belongs to real number such that X is greater than -5 and less than 1. Remember to use curly braces in set notation. Now we will see the difference between interval notation versus set notation with some examples. Okay. So first question is -2. So how we will write this in interval notation? You see, this is x is less than equal to -2. Sorry, x is greater than equal to -2 and less than equal to 4. So we will use closed bracket here. Since it is inclusive, while in set notation, we will write it as x belongs to all the real numbers such that x is greater than equal to -2 and less than equal to 4. Second example is this comes from union of sets example. So you see x is less than 4. That means x can take any value lesser than 4. And the limit is not defined, that's why infinity. -infinity, comma 4. For all, we will be using union sign. And when we are saying x is greater than equal to 9, that means it is inclusive. But the second limit is not defined. That's why infinity. We always use parentheses next to infinity. In set notation, we will say x belongs to all real numbers such that x is less than 4 and x is greater than equal to 9. Um, let's take another example. X is greater than 3 and x is less than 14. So in interval notation, this is clear. This part is exclusive while this part is inclusive. While in set notation, x belongs to all real numbers such that x is less than equal to 14 and greater than 3. So this is one question for your dare to try. Convert the following set into set notation. A is equal to -4, -3, -2, -1, and 0. We will see the solution of this question in the next video. Thank you for watching. Bye bye.